Okay, we're on number 13. And in that problem, you're solving a double angle equation. There is a correction in this problem. On the right-hand side of the equation, it needs to say square root of 3 over 1 rather than what you were given. You are solving it over the interval 0 to 2 pi. And as you begin this problem, first thing you want to realize is the sign that on this square root of 3, it's positive. So tan is positive in quadrants 1 and also in quadrant 3. Next thing you'll do is assign the values you've been given here to the legs. It's y value according to the definition for tangent, and this is the x value. Likewise on the triangle in quadrant 3. The vertical leg is square root of 3, but it's negative. The horizontal leg is 1, but also negative. Okay, continuing with this problem and realizing that the terminal side on each of these triangles, or the hypotenuse, is the actual location, is the solution, how you get the solution. So we have one solution at pi over 3, because if this is square root of 3, this would have to be a 60-degree angle, which is the same thing as pi over 3. So then this is also pi over 3, because those are vertical angles. But since the arm is the actual solution, the solution in quadrant 4 is 3/3 at pi. An extra third would put you at 4/3. So these are the first two solutions. Now, because we are solving for a double angle, that actually doubles the domain, and this is the domain over which you are allowed to find your solutions. So you're going to double everything in this domain, allowing you to then find solutions anywhere from 0 to 4 pi. So that means we can keep rotating around the circle just as long as we land on the arms that we've decided, where we've decided there are solutions. So rotating one additional time, a rotation of 2 pi, but landing right here on pi over 3 would give me a second solution in quadrant 1. When I add that 2 pi, I'm going to add it as 6/3. So another solution that we have in quadrant 1 is 7/3. So we have this solution in quadrant 1 as well as this one. Both of them are at this same location. Then in quadrant 3, if I was on 4/3 and rotated an additional 2 pi to land right back here again, I would be at, okay, there's my additional 2 pi, I would be at 10/3. Okay, so we have 4 solutions. Now these 4 solutions are only preliminary solutions because we found these as though we were solving the equation tan of x is equal to square root of 3 over 1. We have not yet used that double angle. So what we're going to do now is work the double angle into the problem considering the 4 preliminary solutions that we have. Okay, using each of the solutions in quadrant 1, we're going to set 2x equal to pi over 3. That was one of the solutions in quadrant 1. We're going to set 2x equal to 7 pi over 3. That was the second solution we got in quadrant 1. Then beginning to use the solutions in quadrant 3, we're going to set 2x equal to 4 pi over 3. And then our final true solution will set 2x equal to 10 pi over 3. Now each one of these equations need to be solved to get the final true 4 solutions. So to solve for x, we divide by 2 here, divide by 2 here. But when you divide by 2 and you're dealing with fractions, it's the same thing as multiplying by 1/2. So first true solution, pi over 6. And just continue to divide by 2, which really means you're multiplying by 1/2 all the way down. So it's 7 pi over 6 for the second solution. second true solution. And here 4 pi over 3 times 1/2 gives you 4 pi over 6, which is 2/3. So third true solution, last one, divide by 2, divide by 2, and you get 10 pi over 3, or 10 pi over 6, excuse me, and that reduces to 5 pi over 3. And there's the 4 final solutions: pi over 6, 7 pi over 6, 2 pi over 3, and 5 pi over 3. Okay, going on to number 14. We have what appears to be the expanded version of this difference for cosine. We got cosine in the front, 7 pi over 12 and 5 pi over 12. So we got a homogeneous product in the front, plus sign, homogeneous product in the back. And just by memorization of the formulas, when you have this kind of product in the front and this kind of product in the back, whoops, I made a mistake there, sorry about that. That's supposed to be sine. Then this would be the difference formula for cosine, because the cosine formula is in the expanded version and the condensed version. They have different signs. Two angles are 7 pi over 12 and 5 pi over 12, which is cosine of 2 pi over 12, which is equal to cosine of pi over 6, or in other words, 30 degrees. So to finish this problem, you're going to rotate to 30 degrees. Recognize that you have a short leg of 1 here, a hypotenuse of 2, and a long leg of square root of 3. Across from the 30 is the short leg. You're evaluating the cosine off of this triangle. Cosine is defined as x over r, so if you take the values off the triangle, you'll have square root of 3 on the top and a 2 on the bottom. That's the final answer for number 14. Number 15, you have tan of 50 plus tan of 100 in your numerator. Then you have a 1 lower left corner. That sign is switched. Then you have a product of the same two terms that you had on the top, which is the summation formula for tan. So in its condensed version, this is equivalent to tan of 50 plus 100, which is tan of 150. You're going to finish this problem by rotating to 150, realizing that you are 30 degrees short of making it to the 180 mark, which would have been here. So you're in a 30-degree triangle after rotating 150 degrees. That makes this the short leg. This would be the long leg, and this would be the hypotenuse. So evaluating the tan off of this triangle is like doing the tan, calculating the tan at 150 using the definition of y over x. The y value being represented by the 1, and the x is negative square root of 3. Okay, simplifying that or rationalizing it, you would multiply by square root of 3 over square root of 3, which would give you the square root of 3 on the top. You can even float the negative to the top and leaving you with just 3 on the bottom. And that's the final solution for 15.